Good morning, everyone. This is Professor Ahmed. Today I'm trying to explore the new possibilities of Gemini 2.0, which has been released. So I'll try to use it for teaching purpose. Okay.
Okay, it looks like...
Okay, just wait, please. Good morning, Gemini.
Good morning. I am ready when you are.
Okay, so what can you see from my screen?
I see a Microsoft Word document with a math problem. It appears to be a question about calculating integrals using the composite trapezoidal rule and Simpson's 1/3 rule. There is also some text at the top of the page with the title, Academic Affairs Division, Provost Office.
Okay, what is university? The name of the university that you can see it?
I can see Al Ain University at the top of the page next to the university logo.
Could you please repeat?
I said the name of the university is Al Ain University.
No, not really. It is Dar al Hikmah University. So it is on top written. So can you see from the logo how many languages are written there? Can you see the logo? Hello, Gemini? Okay, I think we have to restart Gemini again. So let me just clear chat and then start again. Okay, welcome back, Gemini. Can you see the logo?
Yes, I can see the logo.
Okay.
It appears to be for an academic institution.
Okay. How many languages are there in the document and the logo?
There's one language in the document that I can see, which is English. I don't see a logo with any text.
Oh, yeah. Sorry to correct you, but there are so the logo is the name of the university, which is written on top in Arabic, and in the bottom is in English. Sorry for that. Okay, so what can you see now on my screen?
Okay, I see now that the logo includes the name of a university in both Arabic at the top and English at the bottom. What else would you like me to see on your screen?
Yeah. Can you help me solving this problem?
I can certainly try to help you with the problem. It looks like you need to compute an integral using both the trapezoidal rule and Simpson's 1/3 rule. Do you want me to walk you through the steps?
No, just for simplicity, just consider A. So solve the problem using only the composite trapezoidal rule.
Okay, let's focus on solving part A using the composite trapezoidal rule. The trapezoidal rule uses the formula h2 x0 plus 2 fx1 plus 2 fx2 plus 2 xn1 plus fxn, where h is the step size. Would you like me to do the calculations, or do you want to do them yourself and just check with me?
I know the results, but I would like to check with you. What is the step size in this problem?
The step size, also called h, is the difference between the x values. In your table, the x values are 0, 0.1, 0.2, 0.3, 0.4, and 0.5. So the step size is 0.1.
Thank you, that's correct. Okay, can you just go through the details of the composite trapezoidal rule and give me the final results, just to compare to what I have?
All right, the composite trapezoidal rule involves using the formula h/2 x0 plus 2f x1 plus 2f x2 plus 2f xn 1 plus f xn. In your case, h is 0.1, and the fx values are 1, 8, 4, 3.5, 5, and 1. Using these values in the formula, we get 0.12, 1 plus 2, 8, plus 2, 4, plus 2, 3.5, plus 2, 5, plus 1. So that's 0.05, 1 plus 16 plus 8 plus 7 plus 10 plus 1, which is 0.05, 43. The final result using the composite trapezoidal rule is 2.15.
Correct. Yeah, that's what I have also as a results. Now, can you provide with me three course learning outcomes, given that this course is called Computational Science Principles, and it is given for final year in student in computer science program. Can you just suggest three course learning outcomes that can be covered by this question?
Okay, considering that this is a computational science principles course, here are three learning outcomes that this question could help address. 1. Students will demonstrate the ability to approximate definite integrals using numerical methods such as the trapezoidal rule, showing their understanding of numerical integration techniques. 2. Students will understand the relationship between the spacing of data points and accuracy in numerical integration, and will be able to evaluate the limitations of the trapezoidal rule for this type of problem. 3. Students will be able to apply learned techniques to solve practical problems, showing their ability to translate a real-world scenario into a computational procedure.
I think the last one, it's much more better than the previous two ones. Thank you so much. Now, can you also try to rate these questions from 1 very easy to 5 very difficult?
Okay, I can certainly rate the questions from 1 to 5, with 1 being very easy and 5 being very difficult. Based on what I see on the screen, I would rate question A, using the composite trapezoidal rule, as a 3. It requires knowing the formula and correctly applying it, but it's a fairly straightforward calculation if you're familiar with the rule. Question B, using Simpson's 1/3 rule, I would also rate as a 3. It is more complex than the trapezoidal rule, but not too complex.
Okay, so is the distribution of the points fair?
Yes, the point distribution of 3 points for the trapezoidal rule and 3 points for Simpson's 1/3 rule seems fair, since both require a similar level of understanding and computation.
Thank you so much. And now, for an average student, how long it takes to solve question number 5? That means A and B.
For an average student familiar with the trapezoidal and Simpson's 1/3 rules, I would estimate it should take about 10 to 15 minutes to complete both parts of question number 5, that is both part A and B. This includes the time to understand the problem, set up the calculations, and perform them correctly.
Okay, great. Thank you. Now, I would like to move into another part, which is octave. Are you familiar with octave? Hello, Gemini. Hello, Gemini.